I'm Sean Roberts. I'm working on my master's here at Eastern Illinois, and I'm working on an independent study with the construction facilities and Dr. Melton, and using some of the machinery here in the CAD and Sim lab in Clem Hall. What the project that we're working on is egg and dart molding. It's out of old Maine. This molding is hand carved, and they're having troubles finding a way of duplicating it or getting the same molding for Old Maine for the project that they're working on, and they have asked me to see if I can get it duplicated. What we're first going to do is we're going to get this designed out on the 3D program SolidWorks. So as we do that, I'm basically going to take the measurements of this. I'm going to actually section this off, and since the overall piece just needs to be this size here, I'm going to measure it, and I'm going to take each one of these pieces, since they're different sizes, I'm going to average them out so I get the same distance going across. So when I do this, that's what I'm going to do to be measuring it. So what I'm going to do first is I'm actually going to have to construct this this piece here using different sections. So I'm going to actually start off with a block, and I've got some of this stuff already drawn, so we can move through this quickly. First thing I do is I draw a block on SolidWorks. This is basically getting any of the extra filler material out. And then from that point, I'm going to create a couple of planes, and the first thing I'm going to do is I'm going to knock out some of the simple stuff. I'm going to take this bottom bead, and I'm going to create it. So now that I've gotten the bottom bead created down at the base of the egg and dart molding, I'm going to then move to the egg and dart itself. The egg and dart is going to actually consist of 4 or 5 extrude cuts, just due to the fact that you can basically break it into 4 or 5 different shapes. You have the egg itself, then you have the trim around the egg, and then you have the dart. So those are actually going to have to be built in a couple different steps. So first, what I'm going to do is I'm going to cut the round, which you can see from the profile side. So once I got that cut, which I now have that done on the computer, I'm going to then cut another round through the center of this, and that's going to cut out the section where the egg's going to rest. So that section will get sketched in, and then the extrude cut will happen. So now I've got a arc cut through the center of this. The next piece I will do is the outside edge of that trim around the egg. So once I've done that, I've gotten that piece drawn in, and basically what I'd do is I'd come from the top and I'd sketch those pieces in and then do an extrude cut. From this point, I'm going to actually sketch the egg, which the egg is sketched in. On the computer you don't see it right now unless I were to enter the sketch view. And from that point, I'm going to go ahead and extrude, which I basically had this drawn. So now we've got the egg drawn in. The next part I'm going to do is I'm going to build this top ridge here, and that's basically just drawing a rectangle on the piece, or on the building block that I have. The next piece I'm going to draw is will be the dart on the inside of the egg and dart. So what I'll do is I'll match curves, and then try to match the curves that I see that are hand carved in here. Now, since this is a hand carved piece, what I'm going to do here is going to be mechanical, so it has since each one of these are different, I'm going to have to basically make it the same for all the pieces so that it can be reproduced easily. So I'm going to go ahead and create the sweep. Now that the sweep's placed in there, I needed to make sure that there's a groove that goes all the way up to the top of the egg, and then that the piece also curves out to create the dart shape. Next, I'm going to create a plane, the center plane. This is so I can mirror that the sweep over. Once I do that, I create the other sweep on the opposite side, so now we almost have a full section of the egg and dart. There's a little bit more left to do, but what I'm going to do is I'm going to come up here and build this section, and then I'm going to do a profile of this and extrude it back. So I go ahead and build this section up, and I go ahead and take it all the way up to the top. So it's now starting to actually resemble what we have drawn here. And this next step, I'm going to go ahead and do the molding at the top of this mold. And basically what I do there is I create the profile, and then I have the profile or the sketch extruded back along the front, so it can be done in one move. Then lastly, what we do is we go ahead and we're going to cut out the ends on the dart, so whenever we mirror this object over, it'll look as though there's a dart in between each egg. So we go ahead and I would draw a triangle in that area, and then I'd extrude cut it back. So now that that is created, we have our egg and dart drawn on SolidWorks. Now what we need to do is we need to get ready to make it for the construction people to approve it. So what we're going to do is we're actually going to create a smaller version of this so we can take it over to our 3D printer and print off a section. That way they have something that they can look and approve and compare it to this piece of molding here. So what we're going to do here is we're going to actually I'm going to minimize this, and I'm going to open up another file, and this is going to be the egg and dart assembly piece. So for the construction approval, we're going to create a small piece on the 3D printer. So what we're going to do is we're going to take the piece that we had, we just drew one section of it. Now what we're going to do is we're going to mirror that over once or twice so we can have a block section that we can show as a demonstration. So what I'll do is I'm going to open up a pre-made section. This right here is one that has been mirrored over just once. So what we're going to do here is we'll actually go up to the file, and we're going to save this as an STL. So when we save this as an STL, this is going to save it into a format that the 3D printer can read, so we can actually print a sample section of what's been drawn on the computer off. So when I hit save, it'll go ahead and save that as I have it saved as egg and dart sample. So I can click save, it'll go ahead and save it, and then we're ready to move over to 3D printer. So the next point is taking the STL file the egg and dart STL file from the SolidWorks program to the computer that we have, our 3D printer. This is our 3D printer. It basically takes a STL file and builds it up using a cartridge of two basic materials. One's a construction and one's a object material. This is the object material. It starts out like this, and it actually heats up this plastic and builds it via multiple layers, and when it comes out of the end, it'll actually come out in a much finer plastic, and this is what is used to build the 3D rendering or a physical model of our egg and dart sample that we're making. So basically what we're going to do is we're going to load, we take our flash drive, plug it in, and then we would load our drawing up and within the printing parameters of this machine. So once that object is placed in the machine or placed in the computer, we go ahead and hit print, just like any other paper printer. And so once it starts and the machine's warmed up and it's reached its temperatures, it'll start extruding the plastic. Now, we already do have a finished piece inside. When a piece is already finished, it wouldn't necessarily come out just like this. Like I said, there's a construction material and then the object material. What we're seeing now is an object material. Once it finishes in this machine, it actually goes into a chemical wash where the tray that the object's constructed on and the object itself is placed in this chemical bath, and the chemical bath actually eats away some of the construction, or dissolves the construction material, to where all you have left is a object itself. This object is slightly porous. We can set the rendering quality on the machine to where it creates a solid object, but this one is actually the resolution set on it is made to where it will actually hold water. So this will float if it's dropped in water, and it'll actually retain water. So there is a drying period after the material is printed off. So from this point, we will go to the construction facilities and have them approve this design, or see if the design is approved for Old Main, to where we can start cutting this out on the Shopbot and creating an actual wood model of this section. So here we go. So now that we've got our printed piece, we're going to take both these pieces. This is our original piece, and this is the piece that we just printed. We're going to take these to the construction facilities, and they're going to go ahead and prove this. And since these are fairly close to being, since they're pretty spot on, what we're going to do next is we're going to actually take these back to the computer, and we're going to create a longer section of this, and so we can actually produce a long piece of molding. Because what they're going to actually do, since there's actually trim work on the side, what they're going to do is they're going to actually miter the corner together, and they're going to create they're going to create smaller sections out of one large piece. So what we're going to do is we're going to create a large molding piece. That way they can chop it and create it to the sizes that they need for Old Main. Now that we've created this, we're going to go back to SolidWorks and create a larger model. And then what we'll do is we'll save that as an STL and take it over to the Shopbot. So let's start on that. So right now we're in the sim lab. This is just next to the CAD lab. What we're getting ready to work with is the Shopbot. This is a CNC router table. It works on three dimensions. It uses the x-axis, the y-axis, and then the z-axis. So it can cut out a 3D object. It may not be able to cut out the underneath side, but you can always flip it and create both sides. So this can cut in 3 dimensions. It's mostly used for wood and aluminum, so light metals, plastics, waxes, things like that, so light materials. We use end mills and V-tip bits in it, depending on what we're cutting out. In this case, what we're going to end up using is we're going to end up using a 1/8 inch ball end mill for this project. So for the egg and dart project, we're going to use the 1/8 inch ball end mill, and we'll actually have it cut out. We use this. There's a spindle on this. That's what the cutting tool is on it. It's controlled by a control box over on the wall. The power for it is up here, and then the the control box is underneath the table on the side. We also have 3 safety switches or emergency shut-off switches aside from the mouse, and the space bar on the computer become emergency safety switches for whenever the machine is in operation. This right here is the computer that we use to, which has all the software to control the Shopbot. It's the software is called Shopbot 3, and it's what we use to cut. But the issue that we had from going from SolidWorks to Shopbot is we have to have another software. So what we're using is we're using Vectric Cut 3D. This will actually take the STL file that we created in SolidWorks and create a tool path in the Shopbot file, so that we can actually cut that our egg and dart molding out on the machine. So what we've already done is I've already opened up the STL file that we created. I've already created the STL file to where it'll match the length of the material that we're cutting on. The material is 84 inches, I believe, and so we're actually going to use the majority of this table or majority of the machine whenever we cut. So it's going to start from this end here and move down. What I've also already done is I've already zeroed the spindle, the end of the end mill, to where we can start cutting immediately once everything starts to warm up. There is a warm-up process for the machine. We have to actually start the machine on an RPM of 6,000 and wait till the spindle is warm, so that we don't burn a bearing or break a bearing in the spindle. So what we'll do is we'll start at 6,000 RPM and we'll work our way up to 20,000 RPM. So this machine does create a lot of dust. We have a shop vac, and it's currently hooked up to the machine, so it can help pick up some of the dust and alleviate some of that. The machine does get kind of noisy. As far as the computer is, when the machine is running, you can't use it for anything but to stop the program. So once you start the program, the computer basically becomes a control board, and you can't do anything. You can't do any other work on it. So you need to make sure that everything's done on that computer before you start your machining process, because once it starts, if you do anything to the computer, it's going to stop your process, or it's going to stop the cut. So from here, what we're going to do is we're going to go into the Vectric Cut 3D program. I've already got the file open. We're going to go to, since we opened it, basically what we got to do is we got to specify things. This program is very step oriented. There's 7 steps to it. First is the orientation and the size of the model. So we're going to we brought the model in. Now what we're going to do is we specify the z-axis, which in this case we want to make sure that the z-axis is correlating with the z-axis on the computer, from the machine to the computer. So the material that we have, the z-axis that we're going to go with is going to be the depth of the machine, because this machine is going to cut from the top. We're going to say that this section here is the top of the model. So the z-axis is going to sit at the top. So it's going to sit along this plane here. So we're going to have the measurement for the model size is going to be from this corner to this corner. That's going to be for the Z. It's 2.5 or 2.5 inches. The next we'll put in will be the y-axis, and that's going to be the vertical. So if I'm looking at the machine, the vertical is going to be what's going back and forth from me. So it's going to be what's moving away and moving towards me. So that dimension there will end up being 3 3/8. The next piece what we're going to put, or the next information will be the X. That's going to be the left and right of this machine if you're facing it in this direction. So basically, since this piece that we're working on is longer, it's 84 inches, we're going to actually put the 84 inches. It's going to start at the 0 here where we've zeroed our machine. This machine's already zeroed to this material. So once that's correct, or once that information is plugged in, then we go ahead and specify the units. Then we specify the top. We're only machining the top in this project. So once we have that, we're going to go ahead and hit next. Now we're going to do the material size and margins. This is the material itself. We're basically specifying how much larger the material is than the model, because the model may consist of only this, but our material may be a large block of wood. So we may just be cutting a section out, and the computer needs to know that, or this program needs to know that, so that we can take care of this. We're going to go ahead and specify the origin. I'm going to use this piece here. Since we need to specify the origin is going to be the lower left-hand corner of the Shopbot. This way, everything that we work with will be in positive. The computer can go ahead and make sure that can go in negative and back and forth, but for the ease of knowing which way the machine's going to move once the program starts, we're going to go ahead and start with the lower left-hand corner and then have all the machine cutting going to the right. So the 0 is going to start at this bottom corner. That'll be the X and Y 0, and then the height will be at 2.5 above the table. So the base of the table is 0, would be 0, 0. We're going to actually place our 0, 0, or our 3 zeros, because this would be Z, or X, Y, and Z. So it's going to be 0, 0, 0. It's actually going to be at 0, 0, 2.5, but we're going to go ahead and zero the machine out at that point. So that way, whenever this machine cuts, the Z-axis will actually go into the negative numbers, because it'll be dropping down below 0 on the Z. All right, so then the next step is the material size and margins. So we're removing, or we're telling if there's any extra material around the outside edge of it, whether there's extra material above it, anything along the lines of that. So we're actually telling the material size and the origin. Now the origin and the origin of the machine need to be the same, so that whenever everything's cut, things are cut in the same size, and you're not starting in the middle of your workpiece. So you're getting the most out of your work, or out of your tool, or the material that you're cutting from. Once that's set, we go ahead and set the cutting plane, which will be at the bottom of the object. So the cutting plane will be set to where it goes all the way down, otherwise it may have our depth dimensions. So once we apply that, we hit next. Then what we're going to do is we're going to do the roughing toolpath. This one, since our material is already pre-cut or pre-roughed, we don't have to necessarily do that, but the way this program works is if you skip the roughing tool path, it will go ahead and try creating a roughing tool, or it'll try to remove that material that's been specified within the finishing tool path. So we're going to go ahead and say we're going to go ahead and create a roughing tool path so the computer knows that that material has been removed. So it doesn't really matter what tool we're using. We can use an inch end mill. It doesn't really matter, and it doesn't really matter which way the strategy of the tool path is going. That means whether it's going to be cutting along the x-axis back and forth, or if it's going to be cutting along the y up and down. So we'll go ahead and calculate that, and once that gets calculated, we're going to go to the finish tool, or the finishing tool path. So this takes a second or two to load. While we're explaining the finishing tool path, what we're going to end up using for the tool is an 1/8 inch ball end mill. That basically means we have there's a rounded tip, so it's going to have a radius on the inside, so we're not going to have any corners. It's actually going to end up rounding. So for instance, on our model, it won't actually go to the full depth of any of the cuts inside of it. It will actually stop just short of creating a true angle inside there. There will actually be a radius on just about every inverted angle. So even along this top ridge, there's going to be a radius on the inside of that ridge, even though it's a 90-degree angle. So now that that's loaded, what we're going to do is we're going to go ahead and specify that we want this end mill. There are a variety of end mills that we can use. We do have a V-bit end mill, and we also have a V mill, and which I have them over on the desk. But basically, what it is it looks like a pencil bit, and it cuts a very defined edge. It actually, if you don't get the step over right, it will create ridges within your cutting, or within your workpiece. And end mills, the properties that usually lead with that, it'll also, if you have rounds such as the round on the egg and dart, it will actually create a stair-stepping effect as it cuts up. That's why one of the other reasons why we're using a ball nose bit, because it won't create that stair-step effect as it comes up. It'll actually be more of a wave, but it'll be a very subtle wave, and you probably won't even be able to tell the difference even by touch. It's very hard to notice, but it takes away any stair-stepping from changes in a rounded arc. So basically what we're going to do here is, now that we're finished rendering for the roughing toolpath, we're going to go to the finishing toolpath. We're going to select our 1/8 inch ball nose end mill, and we're going to also set the step over. Now with the step over, one of the things you want to take into consideration is how much material you're removing and how fast you're wanting to move the machine. So the less material you take off with a step over, the faster your machine can actually move on a horizontal cut. So, but also at the same time, the more detailed it'll be. So the less step over, the more detail you're going to get. So if we go if we move over 1/16 of an inch, we're not going to get near the amount of detail that we would get on as if we would go over a 32nd of an inch. So we're actually going to go over a 32nd of an inch. So this machine is only going to move over whenever it comes back on its next pass. It'll only cut a 32nd of material off of the existing workpiece. This will create fewer lines. You can almost look at it as a computer screen. The more pixels you have in a tighter area, the higher the resolution it's going to be. So basically what you're going, and then the fewer the passes, or the more material take off in one swipe, the more you're going to notice any tool marks from the tool bit itself. So now that once we get that set, we're going to tell what raster angle, what angle it's going to remove the material at. We're going to have actually remove material on the x-axis, so it's going to actually be cutting as it goes left and right on the machine. Once we get that set, we'll go ahead and we calculate it and we hit next. The next step is step number 5. It's actually a cutout toolpath. For this project, we don't need a cutout toolpath. This is if you're doing a sign of some sort. It will actually cut everything out in the center and then go around the outside edge and cut that object out. Since we're not worried about, or since we're not going to use that, we don't need to worry about that. The next is the preview. This is where we get to see how the material will look once it is cut from the object. So we can go ahead and hit finishing toolpath preview, and you'll actually see the material being removed, or the toolpath created, and see the material being removed from the object. And if this looks similar to what you have as far as the 3D rendering and your models, then you're okay. What you do from that point there is you make sure the scale is set to 1, and then you hit next and go to the save toolpath. From this point here, it's going to ask you what the post processor is. What will be done is we're going to save it as Shopbot arcs, or arcs inch, and it's going to be an SBP file. And once that's specified, that's the specific toolpath for this machine. There are actually 4 different types of Shopbot tool paths that you can, or tool files that you can save this under. We're going inch because our object is an inch, and we're using arcs. The other ones are alpha control, which this is not what this Shopbot uses. So we're going to stick with Shopbot arcs inch and SBP, and then we're going to just go ahead and save the finishing toolpath. We don't need the roughing toolpath because our material is already roughed. So we'll go ahead and hit save, and then we can go ahead and then it'll ask you to specify where you're saving it and all that. We already have a finished one saved with the correct parameters, so I'm going to go ahead and close that out. So now that we're done with this, we can go ahead and save the project as for the project under the Vetric software. We'll go ahead and save that project there as we're going to save the 84-inch dart .vd3 or v3d, and then we'll go ahead and exit the program. Okay, next what we're going to do is we're going to go ahead and open up the Shopbot. We're going to actually run a preview of our 3D model once the Shopbot is turned on. So you're going to make sure the Shopbot's turned on, the spindle is powered up, but not the spindle itself is not turned on. And then what you're going to do is you're going to change the Shopbot on the computer from move cut to preview mode. This way, whenever you load a part file and you execute it, it's not going to actually run the machine. So you can see it'll actually give you a preview of our part of our egg and dart molding in a Shopbot preview window. So what we'll do is we're going to go ahead and load part file. We're going to load the final egg and dart finishing toolpath. We'll open it. It's going to ask for proportions. This is going to be if we want to scale it up or anything like that. We've already got everything set the size we need. So we're going to go ahead and hit start. And what's going to happen is it's going to allow for, the program allows for spindle time. This machine should not move. It's going to actually open up another window. The window is going to show a Shopbot or a part file, and it's going to show a 3D rendering of that tool path, and it's going to cut it out of the material. next what we're going to do is we would fasten down our material to make sure that our workpiece won't move from our object, and then we're going to make sure everything is zeroed with the machine. So the corner of the workpiece is zeroed with the tip of the end mill, so that whenever the machine we can go ahead and start the machine up and get it running. So now we're going to go ahead and place our material on the table. We're going to fasten it, and then we'll go ahead and start up the machine, or we'll go ahead and start up the spindle and get it warm. So now that we have the material placed on the machine, and the spindle zeroed, what we're going to do is we're going to go ahead and turn on the VFD. So we're going to start out at 6,000 and work our way up. So we're going to go ahead and start. This is going to take it probably about 10 to 15 minutes, and then we're going to go ahead and step it up to 12,000 and wait another 10 to 15 minutes. So as it's powering up, it sounds like this. You shouldn't hear any grinding noises. It should sound very smooth. Everything should be clear of the spindle before you start it. The chuck you should make sure your workpiece is tightened. Once that starts, or once this goes, we're going to go ahead and wait for it to warm up. Okay, so now we've finished with our piece that just off the Shopbot. From this point here, we're going to go on to making a piece that looks similar to the original piece. So we've already got that completed. This is a finished piece. It's unstained, but this is basically what will be going up in Old Main. So we've gone from our original piece, which this came directly from Old Main as an example for me to work with. We went from this piece to a prototype, one that we can approve, we can manipulate and see if it works in works in Old Main. We went from this piece to a cut off the Shopbot, and then from the Shopbot to a final piece that will be stained and then mounted and put up in the trim work. So we've gone from original to duplicated piece. And that's the basis of this integrated learning project that we've done with the Shopbot and the construction and Old Main, restoring Old Main. Thank you. have to construct this this piece here using different sections. So I'm going to actually start off with a block, and I've got some of this stuff already drawn, so we can move through this quickly. First thing I do is I draw a block on the on SolidWorks. This is basically getting any of the extra filler material out. And then from that point, I'm going to create a couple of planes, and the first thing I'm going to do is I'm going to knock out some of the simple stuff. I'm going to take this bottom bead, and I'm going to create it. So now that I've gotten the bottom bead created down at the base of the egg and dart molding, I'm going to then move to the egg and dart itself. The egg and dart is going to actually Hi, I'm Sean Roberts. I'm working on my master's here at Eastern Illinois, and I'm working on an independent study with the construction facilities and Dr. Melton, and using some of the machinery here in the CAD and Sim lab in Clem Hall. What the project that we're working on is egg and dart molding. It's out of Old Maine. This molding is hand carved, and they're having troubles finding a way of duplicating it or getting the same molding for Old Maine for the project that they're working on, and they have asked me to see if I can get it duplicated. What we're first going to do is we're going to get this designed out on the 3D program SolidWorks. So as we do that, I'm basically going to take the measurements of this. I'm going to actually section this off, and since the overall piece just needs to be this size here, I'm going to measure it, and I'm going to take each one of these pieces, since they're different sizes, I'm going to average them out so I get the same distance going across. So when I do this, that's what I'm going to do to be measuring it. So what I'm going to do first is I'm actually going to so now I've got a arc cut through the center of this. The next piece I will do is the outside edge of that trim around the egg. So once I've done that, I've gotten that piece drawn in, and basically what I'd do is I'd come from the top and I'd sketch those pieces in and then do an extrude cut. From this point, I'm going to actually sketch the egg, which the egg is sketched in. On the computer you don't see it right now unless I were to enter the sketch view. And from that point I'm going to go ahead and extrude, which I basically have this drawn. So now we've got the egg drawn in. The next part I'm going to do is I'm going to build this top ridge here, and that's basically just drawing a rectangle on the piece. It consists of 4 or 5 extrudes / extrude cuts, just due to the fact that you can basically break it into 4 or 5 different shapes. You have the egg itself, then you have the trim around the egg, and then you have the dart. So those are actually going to have to be built in a couple different steps. So first, what I'm going to do is I'm going to cut the round, which you can see from the profile side. So once I got that cut, which I now have that done on the computer, I'm going to then cut another round through the center of this, and that's going to cut out the section where the egg's going to rest. So that section will get sketched in, and then the extrude cut will happen.